today we're going to look at those last things. Solving equations with the dreaded math F word fraction in it. So I'll do one for you.
You go.
You had 44 through 50 yesterday. Let's do 44 together. If you have an equation, so get this in your homework. That's because it has fractions in the number. Let me ask first, how many things do you see?
You see two like things?
How many things total do you see? Three. Of the three, how many are alike?
Two.
And so they're on the same side of the universe, right?
Yeah.
So we could just add them together, but they had the ugly, I don't like it, fraction. Math F word of fractions. I don't like dealing with fractions. So what I want to show you is how to get rid of those. How you can do equations that have fractions and make it very easy by using the Stevenson rule of algebra. And here it is. You can do anything to anything in an equation as long as you do it to everything. You can do anything to anything as long as you do it to everything. Actually, what do you do? Right.
Yeah, if you change the fractions and the decimals, does it change the equation any kind of weird?
You could change it to a decimal. That's one way of addressing it. It's not the method I'm going to show you right now. Because a lot of fractions, sometimes the decimals is
Sometimes the decimals are just ridiculous.
is ridiculous to deal with as a fraction. So what I'm going to try to do is show you a way to get rid of the fractions. Okay? So you can do anything to anything as long as you do it to everything. And you won't change the equality of the equation. Cole, you're staying with me, right?
Yeah.
I will ask you, if I multiply this term, this thing, by 5, Stevenson says you can do anything to anything as long as you do it to everything, right? So I can do anything to anything. Multiply it by 5. If I multiply that to 5, what's 5 times 1/5? And now it's not a fraction.
Well, it.
But I'm not a hillbilly. I know I can be reduced to 1 divided by 1, and then that's 1, and then would I write 1 in front of it?
No.
So the fractions disappear, right? Right? Now, if I multiply that by 5, I can do anything to anything as long as I do it to everything, right? So if I multiply that by 5, what must I do with this?
Multiply by 5.
Will that get rid of the fraction?
No.
No, actually now I've got a 5/8. It's even uglier than what it was, right? So it did, and what must I do with this?
Multiply by 5.
And so that's not a fraction, it'll be a 10, right? But it didn't get rid of this fraction. How then, so what would I multiply this by to get rid of that fraction? I could multiply by 8, right? Right? But if I'm, so that would get rid of that fraction, right? But would it get rid of this one?
No.
No, now I've got 8/5, it's still a fraction, right? You can do anything to anything as long as you do it to everything, and you won't change the equality of the equation. So 5 won't work, 8 won't work. How are you going to find a number? Because you can do anything to anything as long as you do it to everything.
40.
What number? How did, so Elijah says 40. How did he come up with 40?
8 times 5, the denominator.
He took the denominator of the fractions
Multiplied them together.
and multiplied them together. Now that may not be a least common denominator, so I'm going to interrupt the recording. 40, Elijah said. How did he get 40? We took the denominators of the fractions and multiplied them together. So if I multiply this by 40, what do I get? 40 divided by 5.
Ocho.
The fraction is now gone. If I
Cinco.
multiply this by 40, I can do anything to anything as long as I do it to everything.
Cinco.
That's going to be 40 divided by 8.
5.
Fraction is gone. I multiplied these by 40, so what must I multiply this by?
40.
I can do anything to anything as long as I do it to everything. Now I've got the same equation.
For everything.
I've got the same equation, the same equality of statement, because I did something to something and did it to everything. I'm okay, but I got rid of the fractions, Frank.
Yeah, so basically you got the greatest common factor of, well, not the greatest common factor, the the greatest common multiple,
It's actually the least.
least,
In this case, it won't always be the least common multiple, but it doesn't really matter. If you can see a smaller number besides 40, that both 5 and 8 would divide into evenly, and use that number to multiply everything, that would give you a smaller number to have to deal with. But it doesn't matter. It doesn't matter. Okay? Whether you get the least common multiple or whether you get another common multiple. So now I've got yesterday's lesson, right? Now it's simple, right? Do I have like terms?
Yeah.
On the same side, so what do I do?
Add.
Add and stay, or
Yeah.
subtract?
Add and stay.
Why?
Add and stay because same sign.
Same sign. So I add and stay and I get 13 of them, right?
Yep.
Now I've got two things.
Divided by
Are they
13.
like terms?
Nope.
No, so I'm now to the
Multiply
division
by.
or multiply, I'm going to divide by,
13.
and that's my answer. You may feel compelled to go to your calculator and take 80 and divide it by 13 and get an irrational decimal. That's fine. Absolutely okay. All right? To find that answer, 6 something or 7. 26. Today we're going to look at formulas. Now, typically this freaks you out. You got really masterful yesterday in working how to solve an equation. Today I'm going to say solve a formula, and typically over the 20 years I've been doing this in high schools, it freaks you out. It freaks the students out. So if I divide this by 2, what does that do to it? If I divide it by pi, it kills off the pi, right?
You have to divide the other side.
You can do anything to anything as long as you do it to everything. So if I divided the thing on the right side by 2 and pi, I've got to divide the thing on the left side by 2 and pi, and that is solving for radius. Don't let that freak you out just because there's a bunch of letters in there. Everything they learned yesterday just puddles into a puddle on the floor, and they don't know how to apply it to formulas. But it's nothing different. Look at page 26. You see a list of formulas that we're going to be talking about, possibly others. Circumference of circles, distance formula that we use for the speed trap week 1. And we're going to be asking to solve for one of those letters. But what freaks you out, I think, is that there is more than one letter in the sentence. And so for some reason, when I ask you to solve for one of those many letters, you have a mental oatmeal moment. Your brains go to mush. Or it freaks you out for some reason. So let me try to avoid that. For example, example 1 has this formula that has multiple numbers of letters in it. How many letters are there? Can you see the variables that are in that sentence? There's 2. What would be 1? What? C would be one of the letters. What's another letter?
R.
R. Well, what's that funny little...
Pi.
Is that a variable?
No, it's
actually a number,
3.141592.
right? It's a number in mathematics. It's a 3.14 irrational, so it's not a variable, even though it doesn't look like one of our traditional
Isn't
numbers.
it a Greek number though?
It is a Greek letter that we use to represent a number in mathematics world. So we've got 2 letters. How many things do you, let's go back to yesterday's lesson. How many things do you see? How many terms in this sentence?
So
2 of them, separated by an equal sign, right? You see a C thing, and you see an R thing with numbers written in front of it. No plus signs separating those. This is one thing, one term. This is another term. So are there any like terms up there at all?
No.
No. One's an R term, and one's a C term. They're not like. So we have avoided the step of getting rid of parentheses, because there's no grouping symbols. We've avoided the step of moving, changing signs, and using the adding rule, because there's no like terms to move. So we're really right in this problem, jump to the 3rd step. It's very simple, yet it freaks out many of you over the years. All we have to do is divide or multiply to get what we want by itself. The book is going to ask you to solve this formula for one of the letters. In this case, they're asking you to solve it for R. Which in a geometric world, what is R? It's the radius of the circle. So they're saying, hey, solve this circumference formula for the radius. Now that's the way they're going to write it in the book, so that you know what to expect. Okay, Jay? With me? Now, all we have to do is multiply or divide, right? Because what's happening to R